Hello and welcome back. In this session, we are going to learn a happy number. Okay, let's go through the problem statement first very quickly. Here is the problem statement, maximizing it so that we can read it. Okay, write an algorithm to determine if a number is happy. So what do we mean by a happy number? And then the definition is in line number 5. Okay, there is a process in order to tell whether a number is happy or not, and the process is replace the number by the sum of the squares of its digits and repeat this process until the number equals to 1, or it loops endlessly. It goes into infinite loop, and that does not include 1. So those numbers for which the process ends in 1 are happy numbers. Okay, so that's the definition that we saw. Now we have example, input, and what we are expecting for 19 is true because we have the explanation is starting from line number 11. 19, its digits are 1 and 9. 1 square plus 9 square, that is 82. And then now new digits are 8 and 2. 8 square plus 2 square, that's 68. New digits 6 and 8. 6 square plus 8 square, 6 square 36 plus 8 square 64, that's 100. Now new digits are 1, 0 and 0. So 1 square plus 0 square plus 0 square is equal to 1. So this is a happy number. So it's a fairly straightforward process to kind of find out whether the number is happy or not. But it can be lengthy for some numbers, but it seems there is a pattern actually. If the number is not happy, then it goes into infinite loop and it repeats certain numbers. Okay, that's the thing that we can, if we analyze like several numbers, probably we'll realize that fairly quickly, I would say. Okay, so the algorithm is okay. Yeah, that's not the algorithm here. We didn't hard code, but there is a method to hard code actually, because there is a fixed set of numbers in the loop. And then if you hard code and then detect that it's not falling, it's not one of in the process of finding, if a number is not part of that set, then you can tell that that's a happy number also. But we will do a little bit of another technique called we compare the termination time. Like if it's a happy, it relatively terminates faster. If it's not happy, it keeps going in this loop and see whether and then if both are not happy, then at some point they will end up with the same. They will have one same number in the cycle, right? And then that's when we come out of the loop. So if you use that algorithm, we'll see the code, and I think it's very straightforward from the code. The complexity analysis is for any number like integer, that's what we are going to deal with. We need to process each digit in the number, and the number of digits in the number is given by log n actually, so that's what we call as a cost of finding. In order to that's what is written here in line number 23. In order to find the next value for a given number, it has a cost of order of log n, right? And space complexity, we're not going to add anything. That's why it's constant time, order of 1. uh, that's that's it. That's the problem definition. Let's start with the Java implementation first. Right. Let's minimize this one so that we have a nice looking background here. So I'll start the file name is happy number.java. Let's start line numbers 2, and here is the class happy number. Class starts, class ends, and let me start my main method first. void main method n. I will come back to this one because I need other methods to do the task. Everything is static. I mean the methods, that is a utility methods. That's why we are okay. So we pass the number and we want to detect whether it's happy or not. So what's the logic? We have two kind of we compare. So one we call it slow runner, and we initialize that with a number. And next we call the fast runner, and that is get. We'll write get next. Okay. Now okay. And let me actually we'll come back here. And this is also private static. And get next the visibility, the access modifier, it doesn't matter. Whatever you want to write, that's okay, because we're not really controlling anything. We're writing utility method. Our main purpose is to implement the algorithm. That's our focus. Num, and we want to get the next number. So next number, how do we get that? By squaring its digits, right? So that's what we're going to implement here. Fairly easy. Usually it is done in first programming course or some first programming course in college. While number is greater than 0, we do something, or if there's something digit, we get the digit num more. This gives the digit, the last one, num more 10, the 10th digits, right? Next in iteration, next time it gives the digit in the this one gives in the unit position, next one 10, and so on. Okay, num is already declared. So num changes every time. We will shift that, we divide by 10, so that we are shifting to left, and our sum of digit is, we have to square and sum, right? So t times t, and we're going to return. We have to come out. Once we come out of the for loop, a while loop, we return the sum, and we need to complete this one here. And okay, fast is one number ahead, and if both are terminating, then fast is going to terminate faster, because we're doing for the same number, right? So that will reach to one fast, right? And then if it's not a happy number, then both of them will go in loop, and at some point they will have the same number, because it's repeating, so they'll definitely have some common number. It's fairly, I would say, fairly smart idea actually, and I think it was proposed by one of the famous computer scientists, Bob Floyd or somebody. While by the way, Bob Floyd was a professor at Stanford, and I guess he's the only famous professor, only famous Turing Award winner. Well, there are all Turing Award winners are famous, but only famous computer scientist who didn't have PhD was professor at Stanford, and also got a Turing Award. While fast runner is not equal to 1, okay, because fast runner could terminate fast. If it terminates, then we know that is the happy number. Or slow runner is not equal to fast runner. Because if they equal at some point, that means they are in a loop basically, and all we do is we just get the next one. Let's compare. We keep moving forward and we compare. Okay, and for fast runner we move ahead little farther. Not get. If you're doing get next, we're doing get next twice for this one. Okay. Okay, once you are done, we can do it here. We just check whether first runner is equal to skill1, because that's the one that's going to terminate the first, right? So yeah, now we need to fill our main method. So I would like to give my num is equal to 4 is actually is not happy number, because 4 square becomes 8, 8 square. We'll see whether it's happy or not. Actually, I'm not actually sure about it, whether 4 is happy or not. Okay. My num. Okay, and we print. Okay. Right. Okay. Okay. Errors line number 12 and 13 semicolon. 12 and 13 semicolon. 12 semicolon. And 13 as well. Okay. Going back, compiling, and we have more. My num, can I find symbol boolean? Happy, my num, okay, my num, okay, that's fair. Okay, we're going to compile every time we to check the progress. Num, can't find symbol num, slow runner. Okay, that num, let's see. Okay, can't find that num. In slow runner, oh, nums. Actually, I have only one number, so minus num. Compiling one more time and running. Let's see. Okay, 4 is not a happy number. All right. Now, if you want to test other numbers, it's fairly straightforward. Let's test one more number. I think since we're doing it, and because we need to make sure that the program actually works correctly, well, we can write many tests, but we'll quickly check another number. We compiled already for 19. Now we can run it, and 19 is a happy number because it eventually comes to 1 with the following our process. So this one completes our implementation in Java for a happy number, that is to check whether a given number is happy or not. All right, we are done with the Java implementation. In the next video we will do Python implementation.